Hi everybody, in this video we are going to be talking about 18.2.2 properties of log functions. Again, this is another one of those topics that can feel a little overwhelming at first, so just hang with me, and it does take some practice, so just make sure that you're sticking with me and you're writing all the information down. Once you get done taking notes today, I would definitely recommend going back through the notes and reading through them again to really just try to understand what's going on. And if it helps, go back and watch the video. You can put it on a faster speed and just try to listen to the video again to try to understand the information that's occurring. So in this video are properties of logs. These first two properties we've actually already talked about. So this one just says, and I'm just going to give you lots of these rules here, but it just says log base b of 1 is equal to 0. So that's the one that we were talking about, maybe like a video or two ago now, where it says b to the 0. So if I'm changing this into exponential form, b to the 0 is going to equal 1. Or I gave you the example of, like, let's say we had log base 5 of 1. Well, in that log base 5 of 1, it's asking the question, 5 to what power is going to give you 1? And that power over here that we determined from our discover a log rule, that question mark was always equal to 0. And so 5 to the 0 power is going to give us 1. So I'm just reminding you of that rule. And this is the property that we have. Okay, so the next one, we've actually talked about this one too. That was like from a video or two ago, where we had something like, and again, if we change it to exponential form, it says b to the 1 equals b. So that should, that makes sense, right? B to the first equals b. When we looked at it in an example, we had like log base 5 of 5, and then it asks the question, 5 to the what power gives me 5. So it's like 5 to the what power is going to give me 5, and the question mark would equal 1. And so that's how we're getting this rule here, that property. This next one, if we convert it again into exponential, it'd say b to the x equals b to the x, which that makes sense, right? B to the x equals b to the x. If we put some numbers in there, that would be like if we had log base 5 of 5, I'm going to go ahead and put a squared in there, equals x. And I said, okay, well, I want to know what x equals. Well, x is going to equal 2, because what that means is that we have here of 5 to the x equals 5 squared. So what does x equal? Well, x has to equal what this equals. And so x equals 2 for that one. All right. Chewing on my gum today. Sorry, I'm tired. Our next one, if we have log base b of x times y, what we're doing, so I want you to, again, to think about this. Like if we had this situation going on with exponents, and we had 5 squared times 5 to the third. So again, remember, we've got same bases. What did we do with those exponents when we have the same bases? And we added them, right? So that's exactly what we're going to do here. When we have something where we've got the same base and they're being multiplied, so we have logs that are to the same base. Remember what logs are, they're just an exponent, right? So if we have exponents to the same base and they're being multiplied, what's the rule going to state for how we can separate them back out? We can write it as log base b with that same base, and the rule is going to change to addition here. Well, why is that helpful? Because if we had something like this, I'm trying to figure out what I want to do here. Let me put a 5 in there. Oh man, okay. Log base 5, let's do like 10. Well, how I can rewrite that is I can write it as like log base 5 of 5 times 2. And I'm gonna get rid of this. And then we can say, okay, well, I can split that up. And I can write that as log base 5 of 5 plus log base 5 of 2. Can split it up like that. Well, what does log base 5 of 5 equal? Log base 5 of 5, using the rule that we just did up here, log base 5 of 5 is going to equal 1 plus log base 5 of 2. And we could continue going with this. We could say, well, this would be exact form right here. And then I could say, well, I want you to go ahead and estimate that. So you could put this in your calculator and estimate it. And so I would do like log, so it'd be 1 plus log of 2 over log of 5. And we could figure that out too. So we could do log, I'm going to hit 2, and then I'm going to put the log button, and then I'm going to divide it by 5 and hit the log button, then hit equals, and then I'm going to add 1 to it. And then estimating that, that's going to be 1.43. But our exact form would be right here. The other way we could have jumped to estimated form from way back here on this example is that you could just do log of 10, and you're dividing it by log of 5. And we already know what log of 10 would be, right? Because it's log base 10 of 10. Well, that's 1. And then you're dividing it by log of 5. So when you do that, you should get back exactly 1.43. So let's try it. 1 divided by 5 log equals, guess what? Same thing, 1.43. So you guys should try that both ways and make sure you're getting the same estimate there. But that just gives you an example of when or how we could split it up and how it changes from here into this form. All right, so let's go to the next rule. And the next rule is, again, think about when we were taking exponential form and we've got something again to the same base. What did we do with the exponents? We subtracted them. So that's what we're going to do here. When we've got logs and we've got to the same base, we can go ahead and subtract what we have in the argument that's in the parentheses. So again, like if we had log base, we'll use 5 again. Log base 5 of 5 over 7. So if I wanted to, if it made sense to do this, what I could do is say, well, I want to simplify it as much as I can in exact form. Then you could do log base 5 of 5 minus log base 5 of 7. And that we know already that log base 5 of 5 is 1. So it'd be 1 minus log base 5 of 7. And then if we wanted to, I'm not going to do it for this one. If we wanted to, I could put this one in my calculator and then compare it to what this would be in my calculator, and it should come up to the same exact estimated decimal. All right, the other one that we use a bunch is this one right here, and it's where we have, it's kind of like, it's what's called our power rule for logs. And what we have here is that in the argument, it's raised to a power, and what it says we can do, our power rule, is that we can just bring it down in front of our log to multiply it. So for example, if I had something like log base 5 of 2 to the 3rd power, what that says is I can take this exponent and bring it down. And so then I would have 3 times log base 5 of 2 in that case. And then we could use the change of base rule if we wanted to, and if we were wanting to estimate it and say, well, that's going to be 3 times log of 2 over log of 5. And then we could actually figure out what that is. But anyway, that's just me showing you, if you have something like this, you can bring the exponent down and put it in front. So we're going to try a whole bunch of these examples. And what I want you to do is make sure you're keeping this page handy, because I'm going to have you reference, like, what rule is it? So I'm going to give you some examples, and then I want you to tell me what rule do you see is going to be applied for this. So number 1, let's say we've got log base 2 of 8 times 4. So log base 2 of 8 times 4. So what I would like for you to do is look up above and see which property you think we're going to apply for this one. So log base 2 of 8 times 4. So which one does that look like? And I'm hoping that you're going to say this one right here, number 4, because that would be correct. So right now what we have is we've got the side that looks like this, the left-hand side, and we're going to split it up so it looks like this and this. So we're going to write it as log base 2 of 8 plus log base 2 of 4. And if you are bad about doing these in your head, if you can't do them in your head very well, then go ahead and do your change of base. You are more than welcome to put this in your calculator, and you can do for this first one right here. This would be log of 8 over log of 2. And this one would be log of 4 over log of 2. So you can totally do that. Otherwise, what you're doing is you're asking yourself the question for this one. 2 to what power gives me 8? 2 to what power gives me 8? And that should be 3. And then this next part here, you're asking 2 to what power gives me 4? And the answer to that is 2. So then our answer is 5. That's our answer. So even if, and this is going to give you a different way to do it. If we had come back here and I just said, oh my goodness, you guys, let's just do this. Log base 2 of 32, we could have done it that way. I didn't want you to do it that way though to start with. So it's going to be 2 to the what power gives you 32. 2 to the what power gives you 32. And you would find out that the question mark equals 5 for that. All right, let's try another one. So our next example I want to look at is going to be log base 3 of 9 times x. And which property do you think we're going to use again? I should have my notes so I can reference the numbers for you. Which property? And I can't find it because I can't find the right page. Okay, that should be our product property of logs, number 4. So number 4, same thing with this one, you used property number 4. And we are going to say, split it up and say log base 3 of 9 plus log base 3 of x. So then you're asking yourself for this one, 3 to what power gives me 9? And the answer to that is 2. Plus log base 3 of x. Can I do anything with the log base 3 of x? No, I can't. So it's going to stay right there. Let's try another example. So number 3, we're going to have log base 2 of x over 2. Which one does this look like? Like, which one are we going to be using for this one? And you should say number 5. So we're going to be using property number 5. And it's going to be log base 2 of x minus log base 2 of 2. So the log base 2 of x is going to stay like this. Log base 2 of 2, that's using another property. That's using property number 2. So then in this one, we're using property number 2. And log base 2 of 2 should just give us 1 because it's asking 2 to what power gives me 2. And so that's 1. And that's our final answer. Is that? Let's try another one. We're going to have a log base 3 of 81 over a. Log base 3 of 81 over a. So try that one. See what you get. So your next step should have been this. Log base 3 of 81 minus log base 3 of a. So this first part asks the question, 3 to what power gives me 81? And if you're not sure, put it as your change of base. Do log of 81 divided by log of 3. And what you should get for your answer is 4. 4 minus log base 3 of a. All right, so our next one's going to be log base 3 of 9 to the 4th. Which one does this look like? Which property? Should be number 6. So we are going to take this down and we're going to bring it down here. So then we're going to get 4 times log base 3 of 9. Can we go any further? You should say yes. So this asks the question, 3 to what power gives me 9? And that is 2. And then this is going to give you 8. Okay, let's try another one. Log base 4 of 64 to the x. Which one does this look like? And it should be number 6 again. So we're going to bring this down. So we're going to have x times log base 4 of 64. And then you should be asking yourself, 4 to what power is going to give me 64? And that should be 3. And then we'll rewrite it as 3x. We don't want to write it as x times 3, so it'll be 3x. All right, number 7. 7 kind of combines several here. So it's going to be log base 4 of 4x to the 3rd. Log base 4 of 4x to the 3rd. So it's going to be 2 different ones. So the one I'm going to tell you to use first is your product property one. So let's split it up, and we're going to say log base 4 of 4 plus log base 4 of x to the 3rd. Then we're going to take this 3 and we're going to bring it down. Log base 4 of 4, you should know what that one is by now. That's going to be 1 plus 3 log base 4 of x. And that's our answer. So number 8, this one we've got log base 7 of m over n raised to the 1/2 power. Oh, not raised to the 1/2 power. That's where we're going to head. I'm sorry, log base 7 of the square root of m over n. And I already gave you the answer, but you should be asking yourself, what power are we raising that to? So that comes in from another previous video where we would rewrite this as m over n, and we're raising it to the 1/2 power. And so if you would like to, what I'd like to do is to go ahead and distribute that 1/2 into each of these. And I like to say log base 7 of m to the 1/2 power all over n to the 1/2 power. And then I'm going to use my quotient rule, and I'm going to split it up using subtraction. So then I've got log base 7 of m to the 1/2 minus log base 7 of n to the 1/2. And then we're going to bring these 1/2 down in front of my logs. So then we end up with 1/2 log base 7 of m minus 1/2 log base 7 of n for that one. That one had quite a few steps. Number 9. We have got log base 5 of a squared over bc. That's all going to be in parentheses. That's all part of our argument. So log base 5 of a squared all over bc. So you should pause the video and try this one and see if you can do this one on your own, and then check. So this one should be log base 5 of a squared minus log base 5 of bc. So then I'm going to bring this 2 down. So then I've got 2 times log base 5 of A minus log base 5 of B. And by the way, we have to be careful here. This minus is over this entire log, right? So I'm going to go like this so I don't forget, because I'm going to have to distribute that negative in. So log base 5 of B, and then it's going to be plus log base 5 of C. So why I put that brackets around here is because I need to make sure I distribute this in now. And then my final answer would be 2 times log base 5 of A minus log base 5 of B minus log base 5 of C. I'm doing okay on space. Let's try number 10. Let's try number 10. I think I can squeeze that in here. So number 10. 10 is going to be log of AB over CD. Ready, set, go. Try it. See what you get. I'm going to work through it, and then I want you guys to keep going and see how you do. All right, so I wrote the solution up for you. Check your work when you're done and see how you did. Number 11, I'm going to try to squeeze up here. Sorry, we've got a ton of examples for this today because it's kind of a hard topic. So this next one is going to be log base 6 of AB raised to the 4th. This is, again, one of the ones, because the 4 is on the outside of the parentheses, I would distribute it in so that you don't forget that it's going to go to both pieces. So it's going to be log base 6 of A to the 4th, B to the 4th. So we have it like that. And then we're going to have log base 6 of A to the 4th plus log base 6 of B to the 4th. And then we've got one more step. We can bring the 4 down. Let's bring that 4 down. And then we're going to have 4 times log base 6 of A plus 4 times log base 6 of B. And that's going to be our answer for that one. We're going to look at number 12. So number 12 is going to be log base 6 of, where are you? I lost my example. Okay, log base 6 of A over B, we're raising that to the 4th power times C. So I'm going to give you that one. I want to see how you do on that one. And you're going to use several of those properties, but just try it and see how you do. If you're in touch with your group members, reach out to them, see if they get the same answer. All right, so the next one we're going to look at, number 13 and 14. Now the directions are use the properties not to expand. So what we've been doing is that we've been expanding our log functions using properties of logs. Use the properties now to condense them. So use the properties to condense. And I don't really even know if you'd use the word condense in this case, but essentially we're putting it all back together, right? Use the properties to condense the log functions. That's my abbreviation for functions, FCNS. All right, so for this one, we've got 4 times log base b of m minus log base b of n. So I want you to see if you can condense it using your properties. So what are we going to do with this? I'm hoping you're going to say it's going to become the exponent here, because that's exactly right. It's going to be log base b of m to the fourth minus log base b of n. And now we've got this subtraction, which is going to be the equivalent of what? And we've also got the same base here, which is the other thing you need to check. So it's going to be log base b of m to the fourth over n. And that's your answer for that one. And then we've got one more for you. And that one is going to be a doozy. Hey guys, sorry, I had to pause the video for a second to deal with a text for a moment for my family, but I'm back and I want to talk about number 14. So trying to find space for it. I think what I'm going to do, I'm going to move 14 over here. So 14, we're going to have to write small because this is a long one horizontally. So it's going to be log base b of x plus 1 plus log base b of 2x plus 1 minus 2/3 log base b of x. Sorry, I wrote right over that other one. So what I want you to do is figure out what can we do to condense that portion. So what can we do with, because we've got the same base here, we've got an addition sign, what are we going to do with our arguments? So I'm hoping you're saying I'm going to multiply them, because that would be correct. So then we're going to have, and I'm going to put it in brackets just because I've got two sets of parentheses. So I've got x plus 1 times 2x plus 1. And then I still have this minus 2/3 log base b of x. So let's take care of this 2/3 and let's bring it up here for our exponent. So then we've got log base b. If you wanted to, we could FOIL these two sets of parentheses. I'm not going to do that. I'm just going to leave it as is. So it's going to be x plus 1 times 2x plus 1. And it's going to be minus log base b of x to the 2/3 power on that one. So then what are we going to do about this subtraction sign? And I'm hoping you're saying that it's going to end up becoming division when we move our arguments together. And that would be right, because it's going to be log base b of x plus 1 times 2x plus 1 all over x to the 2/3 power. And then I'm going to put that all in parentheses because that's all part of my argument, and that would be it. So that is our last example, and then just make sure, I want to know how you guys do on this one. And let me know how you're doing on that, and if you have questions on it, then just be sure to ask me in class next time I see you. Okay, that's it for this video. Thanks guys for tuning in.